Hi, welcome to the Basics of Cutting Tools lecture by Todd Frazee. In this lecture, we're going to be covering two types of basic machine tools that fall into two different categories. The first category is rotary tools. The second category is turning tools. Rotary tools spin in relationship to the workpiece. A rotary cutting tool is referred to as a live tool. Rotary tools have common nomenclature or cutter geometry terminology. They generally have a cutting diameter, which is the diameter of 100% engagement of the tool. They generally have flutes. They can vary in the number of flutes and style of flute. And some flutes are side cutting and some are merely to remove the chips from the hole or the workpiece. There's a cutter sweep angle, which can vary based off performance, number of flutes, and finish. Some cutters have a neck. A neck is an area that's ground down smaller in diameter than the cutting diameter, so that portion of the cutter will not contact the workpiece. And then there's a shank, which is a smooth cylindrical portion that's designed to be held onto by a tool holder for the particular rotary spindle machine. The shank diameter matches the tool holder that goes in the machine. Some designs of cutters, the shank diameter and cutter diameter will be the same. In other instances, they're not. Another specification is the length of cut. It's the overall deepest cut you could make with the side of that particular tool, and the overall length. These are some of just the basic nomenclature details that you'll need to know to order proper tooling. The most common cutter, which is familiar to most people, is a drill bit. It's the most efficient at material removal for holes of any device. They tend to have a smooth shank and typically have two non-cutting flutes. The standard drill historically has been 118 degrees included angle on the tip on a standard drill bit. But with modern drill technology, this angle can vary, so make sure you look at the specifications. There's also a variety of coatings available for cutters and drill bits. Some are for specific materials. Shown in the image above are examples of the same drill with different materials or finishes. The first on the left is a high-speed steel drill bit, polished for a nice finish. High-speed steel is susceptible to rust, and the black oxide finish version is more rust resistant. The cobalt steel version has cobalt mixed in with the steel alloy, allowing it to drill through case-hardened materials. And the one on the right has a coating called titanium nitride, and its primary function is to lubricate the cutting action of the flutes and the material chips coming out of the hole so it does not gall and stick to the cutter. Reamers are another common hole forming device. They make a high tolerance hole that is small in diameter in general. Produces a superior finish to a drill, and must be preceded by a roughing tool, which is typically a drill. There are a variety of styles of reamer. The one on the very bottom is called a Morris taper and is designed to go in the tailstock of a lathe. The reamer above it is a hand reamer with a square post on the back to go into a handle. The reamer at the top is a spiral fluted chucking reamer, and the chucking reamer has a smooth cylindrical shaft like an end mill or a drill so they can go in a tool holder in a machine. The next classification of rotary tools we'll be discussing are milling cutters. Milling cutters come in different shapes and form, and their names mirror their cutting action. If a milling cutter is designed to cut on the sides, it's called a side mill. If the milling cutter is designed to cut on its face, is called a face mill. Likewise, there are T-slot cutters, there are dovetail cutters that cut profiles in the dovetail or T-slot shape. There are chamfer mills that are designed to cut chamfers. The milling cutter we have displayed in the image is an end mill. It's designed to cut on its sides and end of the cutter as it's traversing through material. The end mill is the most versatile milling cutter for vertical and horizontal milling applications. They're available in a variety of flute count and angles and flute lengths. Higher flute count end mills tend to be for harder materials and for finer finishes. End mills with lower flute counts tend to be for roughing and more ductile or free machining materials. They're also available with different end conditions. These are also called nose geometries. The flat nose end mill, or square end mill, has sharp corners. The ball nose has radiuses ground on the corners that match the radius of the cutting diameter. The bullnose cutter has radiuses ground on the corners that is smaller than the cutting radius of the end mill. And there's also a variety of coatings and grinds for specific materials, as shown in the image. I'd like to highlight the two end mills on the far right, which have serrations ground into their side flutes. Those are roughing end mills, and they're specifically for roughing and moving large amounts of material. Another classification of milling cutters are indexables. They come in a variety of styles based off their cutting action, but the inserts have multiple cutting edges. And the inserts are rotated, flipped, and replaced when worn. A shell mill style mount to an arbor holder, as shown, is a face mill that has a hole in the center which mounts to an arbor. The face mill style are designed to cut flat surfaces and remove large volumes of material, as shown in the GIF. Taps. Taps are used for making internal threads. Must be preceded by the correct drill size for the tap type. There are two major types of taps. There's the cutting tap and the forming tap. Cutting taps remove material from the workpiece as in the form of chips. Forming taps deform the material and are often called roll taps. It's very important that you reference the correct drill chart for the correct type of tap. Forming tap uses a different diameter than a cutting tap. The form tap can usually be identified by looking at the edges, and they do not tend to have flutes and look like the thread that they are intended to form. Forming taps are only effective in ductile materials like stainless steel and aluminum. Boring. Boring heads make high tolerance large diameter holes, produces a fine finish, and the boring bars use inserts similar to lathe inserts. Different boring bar styles are available for different types of boring applications. Now we're going to move on to turning tools. Turning tools are fixed in relationship to a spinning workpiece when in the machine. A fixed cutting tool is referred to as a dead tool. When a fixed rotary tool is aligned with the spindle of the center line, it becomes a dead tool, as shown by this tap. Turning tools. They're generally comprised of a holder and an insert. The insert is the gold-colored piece, and the holder is the black oxide piece that mounts in a turret. The different tools are designed for different applications. For example, the ones displayed, the one farthest to the left is a threading tool designed to cut threads on an external shape. The second tool, turning tool in the image, is a left-hand tool because when in reference to the workpiece, it would be pointing to the left. The turning tool that's next to it with the diamond shaped insert is a straight tool. It goes straight in from the outside diameter. The following two tools are a left hand and straight in form tool with a circular shaped cutter to make concave shapes. The boring bars used with a lathe are compatible with the ones used for a boring head. The tool nomenclature may be changed based on the orientation. Displayed in this graphic is a whole variety of different tools, their orientations to a workpiece, and their functions. Tools that are designed to cut on the inside diameter of the part are called inside diameter tools. Tools that are facing to the left are left-handed tools towards the primary spindle. Tools that are facing to the right compared to the primary spindle are right-handed tools. Tools that cut on the outside diameter are also outside diameter tools. Shown, there are several types of tools. One, there's a threading tool, outside profile tools, inside profile tools, grooving tools, and parting tools, as well as boring bars. It's important to plan your tooling needs as you've evaluated a drawing before you start programming. This brings us to the end of the presentation. I hope it was helpful, and we'll see you on the next one.